All right, in this video, we're going to talk about simplifying radicals. What is a radical? Well, radical is your square roots, your cube roots, your fourth roots, your fifth roots, your sixth root, any root. So anytime you have a root symbol, that's a radical. Okay, so to simplify it, what we're trying to do is see if we can evaluate it some. Okay, and I mean, there's simple ones. I mean, if I want to know the square root of 4, I mean, we can figure that out. That is going to be 2, right? That's simplifying that radical. We're just trying to find a simpler way to write it. Now, there's more going on here than what is happening, what we see here. And what we need to actually look at is what is going on when we take the square root of 4. Now, the first thing we need to determine is what is the degree of that radical. Well, it's understood 2 here whenever it is a square root. And whenever we can evaluate these or simplify these, what we're trying to find is a number raised to the power of that same degree of that radical. So we can rewrite this radical, and I'm going to put the 2 there so that way we can, well, let's do it in a different color. Another way to express 4 is 2 squared. When this exponent matches this degree of that radical, that means that when you evaluate it, it's just going to equal this number right here, 2. So another way of thinking about it, and this helps some people, but it's a longer way of writing it, and that's why I don't want you to just rely on that. But basically, you can represent 2 squared, or 4, as 2 times 2, right? And since there's a degree of 2 on our radical, and we have a pair of 2's, that means that this just evaluates to 2. Okay, so let's look at another one, just to get us going. Let's say I want to find the cube root. Let's go to another page. I want to evaluate the cube root of 24. Okay. So we can express 24 as 8 times 3, right? 8 times 3. Now, 3 isn't raised to the third power. It's just to the first power, so I can't pull that out. I can't evaluate that number. But 8, I can break up 8. 8 is the same thing as 2 times 2 times 2. We still have the 3 there. And so this is the same thing as 2 to the third times 3. So notice this degree on this radical and this exponent are the same. And so that means that I can pull that 2 outside of the radical, and it's just going to be 2, but we still have the 3 under the radical, so this will be 2 times the cube root of 3. So that is that radical simplified. Let's try another one. Let's say we have the cube root of 16. Well, we can express 16, don't forget the cube root, as 8 times 2, which is going to be 8. We can represent that as 2 times 2 times 2, and don't forget the other 2. Or you could notice that 16 is 2 to the 4th, either way. But what we end up with is just the cube root 2 to the third times another 2. So now that we have this exponent matching that degree, that means I can pull a 2 out of that root by evaluating it, and so I end up with 2 cube root of 2. And that's going to be that radical simplified. right, let's try one with a variable now. Let's say I got the cube root negative 16 x to the fourth. All right, so it takes a little bit of thinking here. Notice that we have a negative 16. So let's try to break that out. Well, we're going to have the cube root. The negative 16, we can make that negative 2 times 8 times, let's keep it x to the fourth right now. And what we learned before is that 8 is 2 to the third. So we'll have the cube root negative 2 times 2 to the third times x to the fourth. So we already know we got this third here, we got this third here. We can pull out a 2. So we'll end up with 2 times the cube root negative 2 x to the fourth. Now we got to deal with that x to the fourth. Well, we can write that x to the fourth as x to the third times x, or x to the 1, right? Because when you multiply those together, you add their exponents, so it would be x to the fourth. And now that my degree matches the exponent on there, that means I could pull an x out. And so what we end up with is 2x times the cube root of negative 2x. And that's going to be that one evaluated. So that's a simplified radical there. And let's look at one more. And so we have the fourth root of 16x to the fifth over 81. Now what's neat about roots is that you can actually distribute them across division and multiplication. Not addition and subtraction, no, only division and multiplication. So in this case, we can apply that fourth root to the numerator as well as the denominator separately. So we can make this the fourth root of 16x to the fifth divided by the fourth root of 81. And then we could work these separately. So let's look at the numerator first. Let's put our fourth root there. Whoa, let's try to do a better form. All right, 16, we already figured out that is 2 to the fourth. And we have an x to the fifth, so we can write that as x to the fourth times x. And so since I have 4 here, 4 here, and 4 here, that means I can pull out a 2. I can also pull out an x. And what's going to be remaining? Just this x here. Cool. So we'll take care of that next go round. In the denominator, we have the fourth root 81. Now, if you have a hard time figuring out what you can break these numbers into, one thing that's cool is you can use a factor tree. I kind of want to do it in a different color though, so that way it stands out. Where's that 8? All right, so we can take the 81. What can we break that up to? Well, we can break it out to 9 times 9. We can break up each of these 9s to 3 times 3. And so what you can see is this is 3 to the fourth. Right? There's 4 3s there, 3 to the fourth. And so what we have in that denominator is the fourth root of 3 to the fourth. Let me get that exponent a little bit better. And so that means this matches this. That means I can evaluate it, and it's just going to be a 3 now. So let's work that out. So we're going to take out 2, an x. We're going to be left with an x under the root. So 2x times the fourth root of x divided by, here I got a 4 and a 4. Just going to evaluate that 3. And so the denominator is just going to be 3. And that's going to be that radical simplified. All right, that's it for simplifying radicals.